for from
One
the
is that is there is a C that what impact for solar flare as that is there is a C that what impact for we have solar flare as that is there is direction C also what impact we have solar flare as that is there is direction C also what impact we have solar flare as that is there is direction C also what impact we have solar flare as that is there is direction electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is using all the time, 24/7, through using this mission. And this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the disk of the sun, but see only the corona. So this instrument is very difficult to make, challenging, but it is made. Now it's going to the orbit. Now what we plan to study using this instrument is the corona, its dynamics. Through this emission line, you can actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it. So these holistically will give you a lot of information regarding not only the sun, but also the heliosphere. Thank you.
That was very interesting, Doctor. Thank you very much.
No longer a button to go live like you have to do in Facebook. Performance 4,000 you're able to handle, which is just the Facebook how well your computer will.
आएगा जिस पे आपको क्लिक करना।
बहुत ज्यादा बंदे मुझे ये डिमांड कर खासी अर्निंग कर सकेंगे। जी हाँ, ये पॉसिबल है अगर आपका पेज मोनेटाइज नहीं है। अगर आप सिर्फ 341 लोग से चल रहा है तो मैं इसको ओपन कर लूंगा, लेकिन उसके अंदर जो ट्रिक्स होती है ना वो आपने जरूर इंप्लीमेंट करनी होती है। उसके बाद आपने क्रोम ब्राउजर पे आना, ये काम क्लासिक पेज पे करें, प्रोफाइल पेज पे ना करें। प्रोफाइल पेज पे आप कर सकते हैं, लेकिन जो रीच हमें आती है ना क्लासिक पेज पे वो आपको नहीं आएगी। तो सबसे पहले के ऊपर, और यहाँ पे आपको दो ऑप्शन मिल रही होंगी। आपने सबसे पहले वाली ऑप्शन पे रेड कलर की डैशबोर्ड से लाइव जाना चाहते हैं, अपनी तस्वीर जाहिर करना चाहते हैं तो इसको सिलेक्ट करें। चल के बताता हूँ, ये बहुत काम की चीज़ होती है। आपने उसके बाद क्या करना है, आपने OBS के अंदर आ जाना है और यहाँ पे आपने प्लस के निशान पे क्लिक कर देना है और यहाँ पे आपको बहुत ज़्यादा ऑप्शनें आ जाएंगी। आपने क्या करना है, आपने अगर ब्राउज करेंगे तो आप वेबसाइट या किसी लिंक के थ्रू इसको लाइव करेंगे, और अगर आपके पास कोई मतलब प्री रिकॉर्डेड वीडियो पड़ी हुई है, आपने अपने फोल्डर में जाके यहाँ से उसको सिलेक्ट करके उसको लाइव कर सकते हैं। तो हमने मतलब किसी लिंक के थ्रू हमने लाइव कर रहा है, तो हम सिंपल ब्राउज़र को सिलेक्ट करेंगे। क्या करूंगा, मैं ब्राउज़र के ऑप्शन पे चला जाऊंगा और यहाँ पे इसको सिलेक्ट करूंगा। तो यहाँ पे आप देखेंगे हमारे सामने ब्राउज़र का नाम आ रहा है। आपने पहले ब्राउज़र का नाम कुछ भी पूछ रहा है कि आपने कहाँ से लाइव, इसका ऊपर से ना इस बाहर से लिंक कॉपी कर लेना। मैं इसका लिंक कॉपी कर लेता हूँ और फिर OBS के अंदर अपने OBS के अंदर आ जाना है। यहाँ पे फिर दोबारा हम यहाँ पे इसको एडिट करेंगे और एडिट करने के बाद वही लिंक यहाँ पे पेस्ट कर देंगे। अब जैसे ही पेस्ट करेंगे ना तो वो OBS और वो वेब
Durgesh Tripathi, Dr. Durgesh Tripathi, you are the PI of the page. So
Now when we are talking
वेबसाइट एक दूसरे से कनेक्ट हो जाएंगी। ठीक है, हम सिंपल इसको ओके करेंगे।
colleagues here, this is the opportunity we got. Actually we are trying to understand actually all the three things: radiation, particles and field. Already they mentioned about the radiation. Now we will be talking about field. Just I want to emphasize on the particles. That's why we named it as PAPA. PAPA means plasma analyzer package.
तो यहाँ पे आप चेक कर सकते हैं कि ये कनेक्ट होना सामने वो मैच भी मतलब स्टार्ट हो जाएगा। अब यहाँ पे आप चेक कर सकते हैं कि अगर आपके सामने ये मतलब वेबसाइट मुकम्मल ना आए तो आपने क्या करना, आपने इनडायरेक्ट के ऊपर यहाँ पे ये नीचे एक हैंड सा बना हुआ है मतलब ब्राउजर के नीचे, आपने इसको इस तरह से एडजस्ट कर लेना। ठीक है, अगर एड्स वगैरह आए अच्छा लगे, ठीक, कंट्रोल प्लस शिफ्ट इकट्ठे दबाएंगे तो आप जिस तरफ से भी खींचेंगे उसी तरफ से ही लंबा होगा, मार्क और लोगो वगैरह ना आए। तो आप चेक कर सकते हैं कि ये हमारा मैच अब OBS के बाद उसके बाद आपने क्या करना है, अगर कुछ इस तरह से आए तो आपने इंटरेक्ट पे क्लिक करना है। जैसे ही मतलब जहाँ पे ब्राउजर 1 लिखा हुआ है इसके ऊपर इंटरेक्ट का ऑप्शन है। आप पूरी वेबसाइट को OBS के थ्रू भी मैनेज कर सकते हैं। जहाँ पे स्क्रीन एडजस्ट करना चाहें तो इसको मतलब एडजस्ट कर सकते हैं। के बाद मैं दोबारा सेटिंग फेसबुक पे ही लाइव होगी। अब स्क्रीन की जो हमने कॉपी की हुई थी आपने यहाँ पे पेस्ट कर देनी है। ठीक है, यहाँ पे अभी मैं दोबारा आपके सामने कॉपी कर आपको दिखा देता हूँ ताकि आपको मजीद समझ करने के बाद यहाँ पे मैंने दोबारा वो पेस्ट कर दिया। सॉरी, पहले हमारा OBS और वेबसाइट कनेक्ट थी, अब वेबसाइट OBS और पेज एक दूसरे से कनेक्ट हो चुके हैं। अब सिंपल क्या करना है, हमने यहाँ पे इनकी चंद सेटिंग्स करनी है। सेटिंग क्या करनी है, सिटीज को ब्लॉक करना है जो कि बहुत जरूरी होगा, जिससे हमें स्ट्राइक नहीं आएगा। और उसके बाद चंद लिंक्स ऐड करने होंगे जिसके मतलब हम ऊपर अपनी मतलब ट्रैफिक गेन करना चाहते हैं या अर्निंग करना चाहते हैं। लाइव स्टार्ट नहीं होगी लेकिन OBS के अंदर हमारे पेज वीडियो आना स्टार्ट हो जाएगी। तो यहाँ पे मैंने स्ट्रीम स्टार्ट किया, आपके सामने ऐड लिंक का ऑप्शन आ जाएगा। अब यहाँ पे ये देखें एड्स लिंक का ऑप्शन कैसे है। अब वो फॉर एग्जाम्पल आप किसी को रेफरल कर रहे हैं, भूल गया था, आपने यहाँ पे टाइटल भी डाल देना जो मैच चल रहा है जिससे रिलेटेड आप डाल सकते हैं। आपको स्ट्राइक नहीं आएगी जब आप सिटीज को ब्लॉक। मैं इसी को कॉपी करूंगा और डिस्क्रिप्शन में डाल दूंगा ताकि मतलब ना लोगों को इजीली मिल सके। अब लिंक ऐड करने की कोशिश मतलब लिंक लगाना है तो जाहिर सी बात है मेरी भी एक वेबसाइट है, मैं उसके यहाँ पे जाने के बाद मैं लिंक ब्लॉक नहीं होगा। हमें
थैंक यू सर।
अगर आपको रिपोर्ट करके ना जाए यहाँ से इजीली मैच गेट कर सके तो आपने सिंपल यहाँ पे ऑडियंस सेटिंग में आ जाए।
You manage the beautiful solar observatory at Nainital.
क्रोम ब्राउजर पे आ जाना है, सेव करना, आपने सिंपल OBS के अंदर जाना है। ठीक है, OBS मैंने आपको बताया था कि आपने
observatories in India.
That's right. India has a long tradition of looking at the sun from the ground. In fact, from Kodaikanal Observatory, we have been observing the sun for more than 100 years. And also we have beautiful, solar observatory at Udaipur, in the lakeside, and at Nainital. We are looking at the sun. But there are limitations of looking at the sun from the ground because you can only see the lower atmosphere of the sun. So this was very, very important that we could go to the space. And this is a fantastic opportunity. Originally, more than 10 years back, we were only looking at a small satellite program. And then Professor U.R. Rao suddenly came up with this idea, why are we taking baby steps? We should think big. We should go to much longer distance. And then this opportunity came in, the Lagrangian 1 mission. The entire country, all the scientific institution got very much highly motivated. There are multiple payloads were then proposed. So eventually now we have a Lagrangian 1 observatory class mission. And as you heard from my colleagues, that it is a multi-wavelength observatory. So that's very important to have the shorter wavelength coverage from the space. And in addition, the ground-based observations are also important. So a combination of the ground-based telescope and the space-based platform is very, very important. And since you asked about the question about the, how Aditya in the overall heliophysics research within the international scenario, we only have 3 spacecraft around Lagrangian 1 point, primarily from NASA and ESA. So I think, again, this is a fantastic achievement from India. If you could reach L1 with the full observatory class mission, it will really open a new window altogether. So I think this is a great opportunity, and we are all looking forward. And as I mentioned, probably we'll request that, a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have a very nice ground-based telescope also to complement the capabilities of Aditya L1.
Thank you very much, sir. Indeed, it's a very great opportunity. And now we move on to Dr. Vipin K. Yadav. So you're in charge of the magnetometer. What is the contribution of magnetometer to Aditya program?
You see, the magnetic field measurements are very crucial in space, and especially at L1 point. What we are going to measure with magnetometer is the interplanetary magnetic field that is coming all the way from Sun and towards the Earth. So typically these values at L1 point are around 5 to 10 nanotesla. But these values increases whenever there is an extreme solar event, such as the coronal mass ejection or say solar magnetic storms. Now these events are crucial to monitor the near Earth space weather, because these can have an effect on the life on Earth. If you remember Quebec, there was an event when the power lines were snapped a few years ago. That was because of an extreme solar event. So to keep an eye on the surroundings of Earth, we need these measurements. And apart from that, for solar wind observations also, these measurements will be crucial. Thank you.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres? And how does Aditya L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to the 27 arcs to 10 to the 32 arcs. Now the thing is, these solar flares, why it is important, as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, there are 2 unique instruments built by URAO Satellite Center that is going to cover the solar flares from 1 keV to extremely high energy, around 200 keV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these 2 instruments, along with the other 2 instruments, VLC and SUIT, we are going to address this $1 million questions, as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya L1 different from these satellites?
Well, that's a very good question, because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument, and multi-direction, and it measures particle, field, and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya L1 absolutely unique because we are going to measure remotely, in situ, and particles and fields. I was also mentioning about multi-direction, and that is coming from the ASPEX payload, which stands for Aditya Solar and Particle Experiments. And this is going to measure particles ranging from 100 EVs going to several MeVs, which is essential for us to know because when the CMEs are happening or the sun is quite angry, the plasma which is coming out from the sun ranges from several EVs to several MeVs. And therefore, we should know in what direction the plasma is coming and whether the plasma is getting accelerated in between when it comes from sun towards earth. And therefore, there is a multi-directional information which is available from the ASPEX payload because it consists of two sensors, SWIS and STEP, essentially giving you in two different energy bands. And therefore, we'll be able to quantify the CME, CIRs, and all the processes which is happening on the sun, which gives out coronal mass ejections. Thank you.
Thank you very much, sir, for your remarks. And now finally we move on to the principal scientist, Dr. Sankara Subramaniam. So how does the Indian science community seek to capitalize on ISRO's space capabilities, especially these observatory missions like Astrostat and Aditya L1?
Yeah, so now ISRO has established that it has a capability to send observatory class missions anywhere in the interplanetary medium. ISRO also is developing capability for small satellite missions like a nanosat, CubeSat, as well as the small satellite capability. And that is something which especially a heliophysics community could utilize it because we can, at a low cost, we can launch many more such instruments which are essential for heliophysics community here in India. So, and also the bigger mission takes its own life cycle because it requires technologies to be developed for a bigger missions. So in between these big missions, if we capitalize on these small satellite missions, and that will enhances the science capability of our country to the next level. And as you know, the science and technologies are always synergized. As the technology improves, your science improves. When I started my career in solar physics, I started with a photospheric magnetic field. Now we are in a position where we can do coronal magnetic field with Aditya L1, which was not feasible when I was doing my PhD. So similarly, as we move on and as the technology starts to improve, we would be able to generate much more capable instruments, much more compact instruments, which will enable us to do much more science than what we can currently do. So we look forward to capitalize on ISRO's capabilities, both at the large scale as well as at the small scale instruments, and also its capability for developing new technologies in the near future.
Thank you very much, sir. That was very interesting. And to end this, I have a last question to Dr. Dipankar Banerjee. And it's about what kinds of outreach is possible through this launch to energize the scientific community?
This is a very, very important question, and we are proud to be Indian now after the Chandrayaan success. I think it's just not the students, it's the entire country is excited. And we got this opportunity to now travel towards sun. So it is very important that the younger generation, comes into the research and also utilizes the data. These scientific missions are for the community, and it has to be the community driven. So some of our scientists, who have been engaged with this mission for decades, we understand what is expected to be, this data. But the younger generation, they need to be trained. And so for that reason, we also have a Aditya support cell at Nainital, and we are going around in the country. We are regularly conducting workshops. So through these workshops and training program, we really want to reach out to other, people who are particularly in the universities or IITs, because they have so far not been directly involved with the Aditya mission. So I think we are really, really going out, and we expect that the youngsters, the next generation will come and utilize this data, because the data is for the community. So unless we have more users, we will not be able to effectively utilize the data, scientific data which is coming, and the way we can help the community at large. Thank you.
Thank you very much, sir.
I think it is very important for us also to reach out to schools and colleges, because the younger generation should be told about this kind of activities which is happening in the country. Chandrayaan-3 launch has galvanized the whole nation, and everybody is interested to know what all is happening in the science and technology within the country. And therefore, this mission, along with the Chandrayaan-3 mission, that is the Aditya L1 mission and Chandrayaan-3 mission, is going to give us a lot of new information which is going to be very beneficial for the country. Thank you very much.
Thank you everybody for participating in this discussion, and now we move on to the control room.
Thank you, Srinidhi, and I thank all the panelists for enlightening us about the high-tech science that Aditya L1 is about to do.
जी हाँ, अभी आपने सुना इसरो के तथा अन्य संस्थानों के वरिष्ठ वैज्ञानिकों ने हमारे बहुत महत्वपूर्ण सवालों के बहुत ही रोचक उत्तर दिए हैं। इस दौरान चतुर्थ चरण के बर्न 1 को कंफर्म किया गया है फिजी टेलीमेट्री स्थित स्टेशन से। इसमें यान में होने वाले त्वरण के बदलाव को मापा जाता है और इससे पता लगाया जाता है कि यान के इंजन में शुरुआत हुई थी या नहीं, और इसकी पुष्टि कर ली गई है। लेकिन अभी भी यान हमारे दृष्टि से बाहर है, हमारे ट्रैकिंग रेंज से बाहर है, लेकिन इसकी यात्रा अभी जारी है। और अब हम स्क्रीन पर देख पा रहे हैं यह पूर्वानुमानित पथ दिखाया जा रहा है। यह अनुमानित पथ है। ग्राउंड स्टेशन से पुष्टि होने के पश्चात यहाँ पर इसकी पुष्टि की जाएगी। आज 11:50 पर प्रमोचित हुए PSLV C57 रॉकेट की यात्रा अभी भी जारी है। प्रथम, द्वितीय तथा तृतीय चरण के सामान्य कार्यकाल के पश्चात इन्हें यान से पृथक कर दिया गया था। और फिर
टर्मिनल acquires telemetry signal.
जी हाँ, इसकी पुष्टि हो गई है। शिपबॉर्न टर्मिनल से हमारे यान को ट्रैक कर लिया गया है।
At present, ground trace and FPD are updated based on real-time data.
अब हमारे ग्राफ को वास्तविक समय से दिखाया जा रहा है। यह वास्तविक डेटा है जो अब हम देख पा रहे हैं।
Welcome back to the live coverage of PSLV C57 Aditya L1 mission. The launch took place at 11:50 hours Indian Standard Time from the second launch pad at Satish Dhawan Space Center, Shar, Sriharikota. The first, second and third stage of the launch vehicle have performed normally, and the launch vehicle was in the no visibility range for the ground tracking stations. Shipborne terminal in Pacific Ocean has started to acquire signal 51 minutes into the flight.
अब कुछ ही क्षणों में हम चतुर्थ चरण के पुनः प्रज्वलन को देखेंगे।
In the past 26 minutes or so, the ground trace for the flight was being updated by extrapolation.
Four-stage engine started for band 2.
यहाँ अभी अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह पुनः प्रज्वलन है PS4 का कोस्टिंग फेज के पश्चात। या वास्तविक समय पे हमें यहाँ आंकड़े उपलब्ध हो रहे हैं कुरू स्टेशन से।
A very happy
Fourth
piece of
stage
news here.
performance normal.
Range Operations Director has confirmed the second burn commencement for the PS4 stage. Around 14 more minutes to go for the spacecraft injection.
जी हाँ, अभी भी लगभग 14 मिनट बाकी हैं हमारे अंतरिक्ष यान आदित्य L1 को अंतक्षेपण के लिए। आपकी जानकारी के लिए बता दें कि इस कालावधि जब अंतरिक्ष यान या हमारा यान हमारी दृष्टि से दूर हो जाता है, इस कालावधि में ग्राउंड स्टेशन की दृष्टि से बाहर जा चुका होता है और यान के ऑन बोर्ड कंप्यूटर पर टेलीमेट्री स्टोरेज पर यान के महत्वपूर्ण आंकड़े सेव किए जाते हैं। जब यह हमारे तय ग्राउंड स्टेशन की रेंज में आते हैं तब इन आंकड़ों का प्रसारण होता है और वहां से इनकी पुष्टि की जाती है कि यान इस दौरान किन गतिविधियों से गुजरा।
Fourth stage performance normal.
The fourth stage performing normally. The second burn is expected to last for 472 seconds.
यह चतुर्थ चरण है PSLV XL रॉकेट का। इसमें 2.5 टन के नोदक का इस्तेमाल हो रहा है। 2.5 टन के यह तरल नोदक का इस्तेमाल हो रहा है। यह तरल नोदक हैं। 2 इंजन लगे होते हैं, हर एक 7.2 इंजन लगे होते हैं, हर एक प्रणोद उत्पन्न करता है। इस तरह कुल प्रणोद 14.6 करता है। इस तरह कुल प्रणोद 14.6 किलो न्यूटन का होता है।
Plus 55 minutes.
इस प्रज्वलन काल में इसे 472 सेकंड तक प्रज्वलित रखा जाएगा। 472 सेकंड तक प्रज्वलित रखा जाएगा। गणमान्य व्यक्ति यहाँ उपलब्ध, गणमान्य व्यक्ति यहाँ उपस्थित हैं।
We are close to 55 minutes 30 seconds. We are close past to the launch. 55 minutes 30 seconds. PS4 past stage. The launch. Currently PS4 stage. Burning for the second time. Burning for the second time.
Normal. Stage
Intended trajectory.
normal.
Closely matching intended trajectory. Prediction. Closely matching the prediction. Presently, this shipborne terminal is acquiring the signal. Presently, this shipborne terminal is acquiring the signal. Few seconds later, there will be another no visibility phase. Few seconds later, there will be another no visibility phase. Starts to acquire signal. CHORA starts to acquire signal.
जी अभी द्वितीय चालू है PS4 स्टेज का। बर्न चालू है PS4 स्टेज का। सेकंड जलकर यह शांत हो जाएगा। 200 और सेकंड जलकर यह शांत हो जाएगा। सूर्य एक बड़ा और हमेशा सूर्य एक बड़ा सितारा रहा है हमारे लिए। हमेशा असल में यह का सितारा रहा है हमारे लिए, जो अनगिनत हाइड्रोजन एटम्स के फ्यूजन रिएक्शन से जो अनगिनत हाइड्रोजन एटम्स के फ्यूजन रिएक्शन से ऊर्जा से इस सौर मंडल को और परिवार ऊर्जा से सौर मंडल को एक परिवार के सूर्य की दूरी लगभग 150 मिलियन किलोमीटर है। सूर्य की दूरी लगभग 150 मिलियन किलोमीटर है। स्रोत है और इस जीवन जो हमारे ऊर्जा स्रोत है और इस जीवन जो हम जानते हैं उसका भी स्रोत है।
Loss of signal for shipborne terminal. Telemetry signal break will be approximately 205 seconds. Telemetry signal break during this non-visibility period. Ground trace and during this parameters will not be updated. Ground trace and flight parameters will not be updated.
यान फिर से अंतर्दृष्टि हो चुका है। यान ट्रैकिंग रेंज से बाहर है। अंतर्दृष्टि हो चुका है, हमारे ट्रैकिंग रेंज से बाहर है। अगला ट्रैकिंग स्टेशन गुरु स्थित फ्रेंच गयाना स्टेशन गुरु स्टेशन से हमें आंकड़े उपलब्ध होंगे कुछ ही समय में। गुरु स्टेशन से हमें आंकड़े उपलब्ध होंगे कुछ ही समय में।
After being injected into the space, the Aditya L1 will not travel the space. The Aditya L1 will not travel transfer maneuvers will be performed to position the spacecraft in a halo orbit. Performed to position the spacecraft in a halo orbit. Aditya L1 will first be made to perform maneuvers in Earth orbit. First be made to perform maneuvers Adjustments in Earth orbit. Will be made in its orbital parameters. Adjustments will be made in its orbital parameters. After ascertaining the normalcy of the craft, after ascertaining the normalcy of the craft and the orbital parameters, payloads and the orbital parameters, to exit Earth's sphere of influence will be initiated. To exit Earth's sphere of influence after exit will be initiated. From SOI, the cruise phase. After exit will start and SOI, the cruise phase. The spacecraft will be injected into a large halo orbit. Will be injected into a large halo orbit. The total travel time from launch to L1. The total travel time from launch to L1 will take about 4 months for Aditya L1.
इस दौरान आइए आपको अवगत करा दे आदित्य L1 के मुख्य उद्देश्य अवगत करा दे आदित्य L1 के मुख्य उद्देश्य मिशन का मुख्य उद्देश्य है सौर गतिविधियों के विभिन्न पहलुओं में सौर गतिविधियों के विभिन्न पहलुओं में गतिविधियों का अंतरिक्ष उपलब्ध कराना के असर का गतिविधियों का अंतरिक्ष मौसम कार्य के लिए असर का अध्ययन बाहर लगे हुए हैं जिस कार्य के लिए इसमें आदित्य L1 बाहर लगे हुए हैं जिसकी मदद से सूर्य के बाहरी परत फोटोस्फीयर के विभिन्न और सूर्य के बाहरी परत प्रेक्षण कर सकेगा। विभिन्न वेवलेंथ वैज्ञानिक उद्देश्य इस प्रकार हैं। सूर्य के ऊपरी परत उद्देश्य इस प्रकार हैं। सूर्य के ऊपरी परत जिसे हम कोरोना के नाम से जानते हैं क्रोमोस्फीयर और कोरोनल तापमान आंशिक रूप से और कोरोनल प्लाज्मा की भौतिकी आंशिक रूप से मास इजेक्शन की शुरुआत भौतिकी कोरोनल मास इजेक्शन की शुरुआत की गतिशीलता के अध्ययन के लिए सूर्य के प्रदान करना और यथास्थिति के लिए प्लाज्मा प्रदान करना और यथास्थिति कण और प्लाज्मा वातावरण के प्रेक्षण करना।
+1 hour.
वर्तमान में आरओडी ने घोषणा की चतुर्थ चरण को बंद कर दिया गया है। चतुर्थ चरण को बंद कर दिया गया है और वह बंद हो चुका है। थ्रस्ट कट ऑफ कर दिया गया है और वह बंद हो चुका है। इसकी भी पुष्टि हो चुकी है कि आदित्य L1 भी पुष्टि हो चुकी है की स्थितियां प्राप्त आदित्य L1 के अंतक्षेपण की स्थितियां
प्राप्त की जा चुकी हैं। We are now eagerly awaiting the injection of the satellite. We are now eagerly awaiting the injection from the range operations director that the thrust cutoff from the range operations director that the thrust cutoff has been achieved. Fourth stage of PSLV has been achieved. We are 1 hour into the flight. We are 1 hour into the flight.
कुछ ही क्षणों में क्रूज स्थित ग्राउंड स्टेशन से इसकी पुष्टि की जाएगी। क्रूज स्थित ग्राउंड स्टेशन से इसकी पुष्टि की जाएगी।
Highly anticipated event next. Highly anticipated event next. The separation event of Aditya L1 spacecraft. Separation event of Aditya L1 spacecraft.
यान अपने निर्धारित कक्षा की ओर कुछ ही क्षणों में इसकी पुष्टि होनी बाकी है। कुछ ही क्षणों में इसकी पुष्टि होनी बाकी है। यान से अंतरिक्ष यान आदित्य L1 का सफलतापूर्ण अंतरिक्ष यान आदित्य L1 का सफलतापूर्ण बाकी है। अंतक्षेपण अभी बाकी है।
For Aditya L1, ISRO has developed advanced flight dynamic software to obtain advanced flight dynamic data from tracking, apply mathematical trajectory data from tracking, present and future location of the spacecraft, calculate present and future location of the spacecraft in a process known as orbit determination. But the correct orbital parameters at the time of injection are of prime importance at the time of injection are of prime importance.
अब तक कुल 22 और मिशनों को नासा ईसा 22 और मिशनों को नासा ईसा जर्मनी और जिसका इंतजार था वह पल आ चुका है और जिसका इंतजार कर दी गई है पल आ चुका है L1 की पुष्टि कर दी गई है Aditya L1
and we have a confirmation of Aditya L1 we have a confirmation of Aditya L1 separation. The mission has been accomplished.
Aditya L1 satellite into the desired intermediate L1 satellite PSLV to the desired intermediate orbit. PSLV C57
Aditya L1 को पूर्ण परिशुद्धता से आदित्य L1 को कक्षा में स्थापित कर दिया गया है इसके निर्धारित कक्षा में स्थापित कर दिया गया है सफर जारी रखेगा L1 पॉइंट के लिए सफर जारी रखेगा L1 पॉइंट के लिए
Address by Chairman ISRO Secretary Department of Space Address by Chairman ISRO Secretary Department of Space Shri S Somnath.
सभी दर्शकों को सभी दर्शकों को अब हम आपको लिए चलते हैं बधाइयां इस मिशन की सफलता के लिए महोदय के अब हम आपको लिए चलते हैं अध्यक्ष महोदय के एड्रेसिंग के लिए
Congratulations. The Aditya L1 spacecraft has been injected in an elliptical orbit. L1 spacecraft has been injected 235 by 19,000 in an elliptical orbit of 235 by 19,000 by the PSLV. Very unique mission mode here. Very precisely by the stage of the PSLV taking mission mode here. Two-burn sequence for injecting the primary satellite for the first time. Taking So I want to congratulate PSLV primary satellite for the first time. For such a I want to congratulate very PSLV different mission approach today to do this for mission such a of Aditya very L1 different mission approach right today orbit. To do this mission. Now from now Aditya L1 the Aditya L1 will take the right orbit journey after now from now the Aditya L1 will take its start its journey to the L1 point. Very start its long journey to the almost 125 days. So let us wish all the very best to Aditya spacecraft days. So let us wish for its long journey and being put around the halo orbit of L1. For its long journey and the mission executives are there, the halo orbit of L1. Mr. Biju, so with me the mission executives are there. The mission director, Mr. Biju, the mission director, and Nigar Shaji, the satellite director of the satellite project. Let them join me. So let them join me. Our honorable minister. Our honorable Minister for Science, Technology and Space is here. Technology and Space. So I request him to speak a few words. So I request him to speak a few words.
Congratulations, India. Congratulations, India. Congratulations, ISRO. Congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji. Thank you, Honorable Prime Minister Narendra Modi ji, by opening up new vistas for India's space sector, by opening up new vistas for India's space sector is not the limit, and telling us the sky is not the limit. Also, Honorable PM. Thanks also, Honorable PM, for giving us the confidence to reach out to the stars, to reach out to the stars, the mysteries of universe, and to discover the mysteries of universe beyond. Thanks also for making us realize the enormous potential of our space. Ladies and gentlemen, Indian scientists had been working, toiling years and years together. For years and years together. Now comes the moment of vindication. Now comes the moment of redeeming, the moment of redeeming to the nation. The pledge to the nation. And coming close on the heels of Chandrayaan 3 landing, successful Chandrayaan 3 landing, the successful launch of Aditya L1, a testimony is also to the whole of science, to the whole of nation approach with which we have sought to adopt in our work culture. ISRO is credited in executing this mission. The science institutes across the country, in one form or the other, come forward to contribute in small measure or one form or the other to this mission. In small measure or big, the Indian Institute of this mission, Astrophysics, name of Bengaluru, Indian Institute of National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the Tata Institute of Fundamental Research, Mumbai, Nagpur, the IIT Kharagpur, IIT Madras, the IIT Kharagpur, IIT Madras, IIT Mumbai, and the list is too long. IIT Mumbai, and the list is too long. Gives me the confidence to say, that this day, 2nd of September, that this day, 2023, the 2nd of September, of reckoning, 2023, when we move on into the next 25 years of Amrit Kaal, move on into the next 25 years of Amrit Kaal, and Mother India will and collective effort, with the collective will and collective effort of our 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, when Somanath, the entire ISRO team, and the entire countrymen.
May I request the Director of Aditya L1, Nigar Shaji, say a few words.
Good afternoon. It's a dream come true for Team Aditya L1, and I'm extremely happy that Aditya L1 is injected in the intended orbit flawlessly by PSLV as always. And Aditya L1 solar panels are deployed, and the spacecraft will be normal. 125 days of long journey and towards L1. Aditya L1 has started its 125 days of long to rise the orbit, and that followed by the trans L1 injection, to rise and finally insertion into the halo trans L1 injection, and finally insertion into the halo. Aditya is commissioned, it will be an asset to the heliophysics of the Aditya is commissioned, it will be an asset to the scientific heliophysics of the country. And I take this opportunity to thank Chairman scientific fraternity, Director URSC, and I take this opportunity to thank Chairman and all the Center Directors URSC for their support and guidance for making this mission possible. And all the Center Directors and my for their support and guidance for making this mission possible. And all the project executives, and my thanks are due to my payload teams, especially the teams from the IAA and UCA, for the relentless effort, especially the teams from the IAA and UCA, as well as the spacecraft, for the relentless effort in building the payload, as well as the special thanks to the expert committee, who have been guiding all through the special thanks to the expert committee, who have been guiding all through the entire industrial partners. And the entire URSC team, all the industrial partners, their invaluable contribution, the entire URSC team, and for I feel really honored and privileged to be part of this mission. I feel really honored and privileged to be part of this mission. I would like to remember Professor Yuvarao. Who sowed the seed for this mission, and who sowed the seed for this mission, and looking forward for a successful halo orbit insertion and further science, great science output from the Aditya L1 mission. Thank you all.
Shri Biju, the Mission Director and the Project Director of PSLV. Shri Biju, the Mission Director and the Project Director of PSLV.
My big salute to all of you for achieving this wonderful mission. My big salute to all of you for achieving this wonderful mission. Intermediate orbit. Aditya, PSLV, we have injected in its Aditya in its intermediate orbit mission as successfully accomplished 59th mission as successfully accomplished Aditya L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team very it was very challenging. It was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliability for PSLV and all our family members. With this, PSLV has increased manifold to venture into new missions and challenging missions. I take this opportunity to thank my project team led by MJ Lal as well as Damodaran, Vehicle Director and Associate Vehicle Director, leading the entire campaign. I wish satellite team excellent time for completing all the operations and completing scientific objectives they have envisaged. Thank you all. Thank you all. Thank you very much.
Thank you everybody for your time watching this mission and also supporting us and congratulating us and we joined the entire country. We are very proud of the fact that we do this mission just following the Chandrayaan 3.